Okay, time to get down to the brass tacks. In this video, we are going to use first principles to crucify Python. And when I say Python, what I really mean is any language that is not Excel VBA. That is your first clue that my underlying arguments relate to structural issues that arise from the nature of work. Engineers choose to focus on the fact VBA lacks certain frappuccino conveniences, like decorators and operator overloading. And yet, it's hard to imagine scenarios where operator overloading would be useful in a business context. Okay? Before I go on, lest anyone think otherwise, I love Python, and I use Python all the time. It's an amazing language. Okay? Python also completely fails when it comes to automating amorphous, nonlinear human tasks that are being done in Excel today. Python is great for things like running a web server or doing concurrent operations with multiprocessing or multi-threading. Many other things. Okay. Here is an algorithmic trading app, currency trading, I made and which I use Python. All right. I didn't use VBA because it would be the wrong tool for the job. Engineers who categorically dismiss VBA are missing the forest for the trees. There are 1 billion Excel users on this planet, okay? And VBA is the only programming language that can run natively within Excel. When you use Python, C# or JavaScript to drive Excel, you're out of process, you're talking over APIs and bridges, and you're dependent on external runtimes and servers, okay? It's like a little bit like driving a BMW with a remote control, okay, compared to, VBA, which is driving the BMW and you're sitting in the car behind the wheel. I was reminded of a funny meme where like Homer Simpson like goes to South America or Australia and he doesn't like that the toilet flows like the other way there. I don't think that's actually true, but regardless, he doesn't like that in the other hemisphere the toilet is flowing the opposite direction. So he like comes up with this incredibly contrived contraption, to try to make the toilet flow the other direction. And I feel it's really similar when people are trying to like shove Python and JavaScript, into an Excel context. It's like, why are we doing that? Okay, cut. Hey, so one more thing. There is this notion in trading of always respect the other side of the trade. Okay, so you might be certain British pound is headed lower, so you get short. All right, but someone, quite possibly someone with asymmetrically better information than you, is taking the other side of that trade. Okay, they're getting long, and you should be careful before discounting or disregarding that. So when I'm sort of throwing around Homer Simpson memes with regard to trying to use Python in Excel, I do want to point out the other side of the trade. Is this guy Felix Zoomstein? He's got this book and he has a product, Python XL Wings, and I read this book and it's a really good book. If you want to learn about pandas in Python, it's a library you can use in Python. Like, dude, I've been reading stuff on pandas for a while, but like his explanations were, far and away like the best that I ever read. So, in fact, if you're starting with Python, this would be a good book, I think. Anyways, all I want to say is that there is, other viewpoints besides mine. I stand by my viewpoint 150%. In part because I don't think this is good for production environments at corporate employers where you have 60 employees that are using a template, okay, and where there's extremely high variation. I think where this could excel, is with a small crew of like 3 to 5 people that are very, very focused, doing things with not much variation, okay. Where you sort of want to have the exact. It's hard to find the words to say what I want, but I think that you get the idea. So that's what I want to say about that. Cut. Okay. On my screen is a PDF of an appraisal for an affordable apartment property located in San Antonio, Texas. I got this report from state agency website, so it's part of the public record. You could come and download it if you wanted to. The word affordable refers to the low-income housing tax credit and or sometimes Section 8. These programs are jointly run by U.S. federal government and the individual states. To grossly oversimplify, affordable programs give housing developers money in exchange for keeping the rents artificially low. All right, we'll see that in a minute. I can't completely avoid talking about the affordable subsidy stuff. Bear with me. Lord knows I will do my best to minimize it. But in order to make my case, I need concrete examples. And real estate appraisals and market studies are extremely good for that. So let's see. If you haven't heard of first order principles or just first principles, they refer to fundamental irreducible truths. Okay, they're like base level facts that cannot be broken down further. All right. If I drop this Red Bull, it will fall onto my keyboard. Gravity's first principle. I like these because they're hard to argue with. Okay. So whenever possible, I'm going to use those. And I'm sure that someone in the well actually crowd, probably someone from Reddit, will nitpick me over some technicality, and I don't care. All right? Maybe I make an assertion and you feel it's only true 90% of the time. It probably doesn't matter, okay? Especially if you're building software in Excel, all right? Because in Excel, users can override incorrect assumptions and handle edge cases by fixing it on the fly mid-report, all right? Now, if you're building your software in Python, like a web app that can generate these appraisal PDFs, then perhaps you are right, all right? Because screwing up just one single intermediate calculation, can throw the whole thing out the window. So I suppose to the nitpicker, I should say, thank you for helping me prove my point. All right, so our game plan is we're going to freaking go through this PDF, all right? It's 225 pages. It is filled with mostly tables and text, okay? There's some images in there too, and some charts. But fundamentally, it's tables and text. So I look at it as, as a manufacturing process, right? My background is in appraisals. That's where I sort of cut my teeth. And actually for this company here. So this report was produced with software that I made. I'm familiar with it. I'm on my home turf. So the sort of first, I'll call it, there's first principles and there's first questions. So the way I want to do this is basically go through this report and an Excel template and look at the flow of data. And I'm going to ask first questions about, okay, if we're doing this in Python, how are you going to handle this? And how are you going to handle, that? Okay. And I'm just going to poke holes, at all of the problems, that arise when you try to do that, as a way of showing, that, if we exclude this and we exclude this and we exclude this, you're basically left with VBA. It's like the freaking holy grail for these, complex, nonlinear processes and analyses where human judgment is involved and where there's a lot of variations and forks in the road. Okay, let's cut. Okay, let's take a gander at these first principles. All right, so these are the principles here that I have. There's like 12 of them. Let's just go through them. A solution that doesn't manufacture tables sucks, okay? So when we're automating these reports, okay, and I'm looking at appraisals, but you're imagining your own report context. fundamentally they're tables and text. So if your user has to make this table by hand, like it's end of game mode. That's not a good solution, all right? Because there's too much of it, and you want your user to be you want to sort of elevate them to a place where they're free to think. They're not burdened by this sort of like building boilerplate tables. And that's not possible if they are building the tables. And that includes reformatting them. You know, if you have a system where you export the tables like from a database, and then you have to go modify them, insert a column, merge some cells, like that's almost as bad as making them yourself. And another issue with that approach is what happens when the data changes. So say I've made all of my tables. There's a bunch of, you know, supply tables. Here's the comps here. So see like Park de Oro. Here's Park de Oro again, okay? Let's say that we decide that Park de Oro is not a good comp, okay? So we've got to throw out Park de Oro and then get a new comp. Every single table that you've made by hand has just been invalidated. And now you would face two painful choices. One, you know, go and hand modify all of these tables, or two, export and reformat them all again. So you're either doing, you know, surgery or you're rebuilding from the ground up. And that's a Pyrrhic, I don't know how to say that word, choice, but they both options suck. Okay, so that's the first principle. Okay, principles 2 through 7 are closely related. Okay, so let's see here. Number 2, a table can be decomposed into data sources. All right, and the 3 sources of data, as I classify them, are remote, local, and derivative. A derivative would just be like a formula. Okay, so for say rent per square foot, you might derive that with a formula of dividing the rent by the number of square feet. Or you might choose to import it directly as a static field, like from the web database. That's a different discussion. But the point is there's 3 types: remote, local, and derivative. The local one subdivides into human conclusions. Okay, so you know, achievable 2-bedroom rent. So you have some remote database like this one here, and you have, you know, this data is in here for the unit mix for this property. But the concluded rent is not, okay? Because it's not like a fundamental fact about this property. It's specific to that job at that point in time. So that's what I mean by local. This is the stuff you input into Excel, all right? I think a good example of that is like here. So we can decompose this table. This is from the same report. There's Parco de Oro again. This is our subject property, and this is like a rent grid where you start with the, you know, asking rent that the property is charging, and then you basically make these adjustments against the subject. All right. So here, you know, the subject has it's a studio unit, okay, and this is a 1-bedroom unit. A 1-bedroom unit is better than a studio unit, so you would adjust this comp's rent down. So 800 just went down to 700. So the square footages, that's going to be inside, you know, your Battleship Galactica, your remote database, okay? And that data gets imported into your Excel workbook. But what about the value of these adjustments, okay? So let's see, where's a good one? I mean, we can use square footages. We can use, I don't see anything for balcony. Oh, here's balcony. So like maybe balconies in Florida are worth, you know, $20 of value, all right? But a balcony in Alaska with the polar bears has almost no value. So see, this is not, again, the value of a balcony has nothing to do with, you know, your property database where you're storing your rent comps. That's local data, and it lives locally within the Excel workbook. It's local to the current job. And you can't build this table without both, okay? So if you're going to manufacture this table, because first principle number 1 says if you're not manufacturing tables, you suck. So if you're going to manufacture this table, you need to be able to query all of those data sources, right? You need to be able to, at runtime, when the user wants the table, you need to know which properties are the comps, what amenities do those comps have relative to the subject, what is the value of those amenities in the current market. And of course, if you find out, oh, you know what, it turns out that, Parco de Oro, it does have balconies, or it doesn't, whatever, the opposite of what it is, you want to be able to fly over to the remote source, edit the amenity, add it, resync that one property, and instantly see your table update. So I have built, I built an appraisal template completely in Excel, and I built one completely in the web, both for Novogradac, okay? And I think today, there's a split between the users. Both of them are still in use today. But I have done it both ways, and it's really, really, really hard to do it in the web. It was one of the hardest things that, hardest undertakings I've ever undertaken. Okay, did I cover this right? Remote local derivative sources. A good example of a derivative source is this adjusted rent at the bottom, 624. That doesn't live in any database, right? Okay, it's not a fact like a property has an amenity, balconies, yes, no. It's not a conclusion that you're concluding to, like the value of the balconies for the adjustments. It's a derived value that's imputed through the tables in Excel. Okay? All right, so what did we do? We did a table can be decomposed to data sources. To build the table, you have to query the data sources. Okay? The next one is you can't query local data sources. So if you're actually writing code that's generating that table, the RCS grid, you can't make it unless you can query it. So if the user, you have to have it saved somewhere. And you have to build a query for the adjustment. What is the value of microwaves and dishwashers in this report that the user has inputted? Okay? So it has to be saved somewhere. So if you have to save that value, the value of, balconies or the value of square footage, it has to be saved. And if it has to be saved, then we get to principle 5. Then you have to capture it in the first place, which means you need to build a user interface, okay, for the user where the human user can input those adjustment values. All right, that's 6. All right, you can't provide a user interface, okay, unless you supply the rated metric. We can't just say what's the concluded rent for 2-bedroom units, 3-bedroom units, whatever. For the subject's units. Because in order to do that meaningfully, the analyst or the concluder, the human who's supplying their subjective judgment and professional expertise, they're going to want to see things. They're going to say, okay, well, what is the average comp 2-bedroom rent? What is the average comp 3-bedroom rent? And then they're going to want to see more details. Well, I know this property next door offers 2-bedroom units. It's a comp. And it's objectively inferior. It's old, it has no amenities, it's falling apart, So for sure, my 2-bedroom rent conclusion for my subject, which is going to be right next door to that property, it's going to be higher, okay? Because we're going to be brand new construction, we're going to be well amenitized, we have large floor plans. We crush that property in every regard, so I'm going to make sure that my concluded rent for 2 bedrooms is above that property. And then maybe you've got luxury high-rise down the street, okay, that's way, way better, okay, like a super property. So your rent for your 2 bedrooms is going to be below the super luxury property and above the dump next door, okay? But all of that information has to be organized and presented and laid out for the user, in an intuitive way that they can just go in there, see the information they need, and make snap judgments. That seems like a good pause time. Okay, principle number 8. Now we're back into a new, that 2 through 7 were all related to data sources. How do you get the data? How do you save the data? How did you capture the data? How did you provide the user interface? And this Number 8 is to build a table, you have to know the design. Okay, so there's a lot of stuff, like here's some just tables I grabbed, samples. How do you know, the caption on the table, proposed rents? Okay, but what if it's just an existing subject? All right, then it would say current rents. Notice the text beneath it, the coupling. A total of 114 units, the same 114 there. I'm going to talk about the report text in a minute, but just let this wash over you that there is a tight connection between this text and the table above. How do you know the ordering of the AMI levels? 30, 50, 60 market. Oh, there's non-rental, artist loft. There's all these little subtle things about how these tables get built. So not only do you have to, get the right data and you get it in there, but you also have to present it in the right way that the analyst and people want it. And that's not easy, and you will not get it right on the first time, especially in a large organization where you have multiple teams in multiple offices who all have different preferences. In fact, a lot of the time I found myself sort of like mediating these things because prior to automation, they just both made the tables different way. But once I chose a way and made that table automatic, and Dom Cobb Princeton, the Dom Cobb principle kicked in, suddenly like the other teams were like, whoa, like that's not quite how we make it. Can we change it? And then it sparks a debate, and that can be really interesting. Okay, so that's 8. To build a table, you have to know the design. I'm not going to talk about this stuff. Yeah. If you don't have an analyst sitting there for each of these tables, and there's well over 100 different tables across the spectrum of different related reports or PDFs that clients buy, you'd have to go through either with an analyst who doesn't have the time to help you and doesn't have a job code for that or whatever. You'd have to review like all 50 PDFs. I'm talking about like if you're a Python developer and you're coming in like, oh, I could automate this, like no problem, I could crush this with Python. Like, sure, you're just looking superficially at like how the table looks, but it's like you've got to think about the data, how you got it, where it came from, like the provenance of the data, and you've got to think about the design. Like, how is the table supposed to look? What do you do when data is missing? So like a professional programmer, it's like they're gonna have to like look through 50 different reports and see like that table, what does it look like? How does it change? Or they have to have an analyst painstakingly explain things to them. All right, and so that does actually this asymmetry thing up here. I would say that this is pretty core to my thesis. All right, if you're a Python programmer, like a professional programmer, and you want to automate these tables and you're like salivating at the bit, it's like, this is not Kansas, Dorothy. Like, you are going to have to learn. This is like the full knowledge of like a, senior analyst that's very experienced at writing appraisals. You're going to have to get pretty damn close to that analyst, okay? I think that was the problem with never mind. I'm coming back to that in 1 minute. This is what a senior analyst who's like a ninja in Excel, like, dude, he barely needs to learn anything about coding to make the tables. He's already got the hard part. The hard part is knowing the design, knowing where the data comes from. That's the hard part, okay? Or if he's using Python, then he's gonna have to know more. So let's say this is like, if he's doing VBA, but if you want to do Python and do it the sort of collectivist, get the Postgres database and the virtual machines and table migrations and like all that other stuff, like, yeah, you are going to have to learn more. So like, this is basically a business domain analyst learning code versus professional programmer learning domain. Okay. Coder domain skills will not transfer for the coder. Yeah, they don't port very well. So, if you're a professional Python programmer, you're going to have to dedicate a big chunk of your time to learning all of this stuff that's sort of narrowly tailored to appraisals, in the context I'm using here. But then when you want to go somewhere else and say, work for a grocery store building their like supply pipeline, very little of your appraisal knowledge is going to like transfer. Now compare that to an analyst. If you're an analyst working in real estate appraisal and you use this add-in that I'm providing you and you build these models and start learning, the fundamentals of code, you'll be able to walk into any freaking Fortune 500 company in America and open up an Excel template and immediately start helping them with problems, okay? If you're using the add-in and if you're using VBA. You could maybe strip the add-in out of there. I think the point that I wanted to get there is that you cannot walk into a Fortune 500 company hired as an analyst, a business analyst, and say, oh, I need Python. I need a virtual machine to run, a Postgres or a web server. Like, that is not just going to happen on your first day in a new office. But your first day in a new office, you absolutely can walk in, and say, here's how I can help you with this, like, whatever it is you're doing, because you can already use VBA. It can't be stopped. Or usually it is not stopped at most large companies. Okay, I was going to say something else I said, but I forgot what it was, so oh well. Let's keep going. Point number 9, if you do build tables, then you had best generate discussion text too. Sorry, first principle 9. We're working through first principles here. So I think I showed you over here, like, if you're going to make this table and there's this text under it, it's kind of absurd to not make the text under it too. That would just suck. So if, humans don't want to write all this, okay? But it's also very important that a human be able to edit it. And so that's a little bit where tables and texts are different. Both of them you have to manufacture programmatically, and both of them require, deep domain knowledge. But the text, they want to revise the text a lot. A lot of times the wording is weird, whatever it is. The user needs to be able to override the automatic text and have whatever they wrote become the new truth. They also need the ability to go back and see, like, say, let's go back to our earlier example, Parc de Oreo. Like, we throw that comp out. It's a bad comp, okay? That's going to invalidate a lot of the text, that's doing vacancy discussions or turnover discussions, where Parco de Oro, like, its statistics were baked into the numbers that are in the text. If Parco de Oro is gone, all that text is invalidated. So if the user had already come along and saved that text, like, they're going to need to go back and adjust it. Now, they don't want to throw away whatever they hated about the text that you generated automatically. It's probably still there. So they need the ability to basically, like, move their current saved discussion to the side, generate the new discussion, like, automatically using your system, and then they're just going to pull the numbers from the new generated text and they're going to put them into their old text. I think I had a pro tip somewhere. Where is it? Pro tip: minimize direct numerical reference in text templates. When you're writing a vacancy discussion or a population growth discussion, it's better to say things like population growth in the local market was slightly below the nation, as opposed to population growth in the local market was 0.02% lower or whatever. Because that 0.02% is very fragile, if you have to change your market area. Or it's just a general tip of, like, try to keep numbers minimized. I don't really want to do this one either. Okay, no, let's keep going. The discussion text, yeah. Best generate the discussion text. The discussion text draws from the same data sources: remote, local human conclusions, derived values. Override, I discussed it. And 12, let me just pause for my voice before I do 12. Okay, before I do number 12, the thing I forgot, and one follow-up on this translation, asymmetry, is that I keep mentioning, like, virtual machines and Postgres and, like, database. And what I mean there is that when you're using the add-in and Excel, everything it's hermetic. So it's sealed within Excel. So we pull data in from remote sources like your web property database, the Census Bureau API, Walk Score, whatever it is. We pull that data in, but we don't write data externally. So we don't write back to the remote database. Instead, we just click a hyperlink and it opens this edit view in the database. You make the change in the database, and then you resync the data in Excel. So I think a big thing is like an IT department would look at you and say, there's no way we're giving someone with no experience in coding, write the ability to do writes into a database, to change the values with code. And that's probably a good idea because, if you make a mistake, you can nuke a whole table of data, and then you got to roll back to, your last checkpoint where you saved, if you're even saving, backup snapshots. It just opens a can of worms. Whereas when you're using the add-in and you're doing it in Excel, it doesn't matter if you nuke a whole table of data. Like, everything is living here on a hidden worksheet. Your data is here. It's like you can't do harm beyond this current workbook. Okay, and you can save a snapshot every 2 minutes if you want, F12. You can see I've got some that I saved there. And the other thing, which was the thing I originally forgot when I was explaining, is that like at my old employer, Novogradic, what I was trying to do is I was trying to do something like this, where I wanted the coders, the developers, and the end users like very close together. I basically wanted to sort of create like a fusion, or like dissolve the differences between them. They're still different, but sort of like a melting pot. And that didn't work very well with the leadership and the culture at Novogradic. I love Novogradic. I think they're a great company, and if I was getting a market study for affordable apartments, I would go to Novogradic. I think that they probably have the best product that is out there on the market right now. And now I've looked at a lot of the other competitors' market studies, and I don't think they're as good. So anyways, this is what I was trying to do at Novogradic, and this is what I'm now trying to do, is like, it's like, just forget it. Like, it's not going to work with collectivism. We're going to take users and turn them into super coder hybrid business analysts, which is going to fit well in the age that we're coming into. Okay? And now we will be on principle 12, the last of the principles. Okay, so principle 12 is that, assuming that you've found a way to manufacture the tables, and assuming the way that you can generate the discussion text, you need to get that content into Word, okay, or whatever. I don't care, what software you're using per se, but probably it's Microsoft Word, and probably that Word document's going to get saved as a PDF, right? So here was our, deliverable. This was a Word document that got saved into a PDF, and it's just got tons of tables and text. You got to get it in there, and you got to get it in there, in the right order, and it's such a big topic that it's hard to cover it here. But basically, there has to be some logic for what content goes where, and so that begs a question of like, probably in most offices, I would say, so. You have a T drive and there's like 50 different templates, okay, base templates. Or you find a similar report that you've done recently and you just take over that report, highlight the whole thing, and then start working through it and writing it for your new subject. I think that's probably how it's handled most places. So at Novogradic, you have all these, rent comparability studies, the appraisals, what we're looking at today, market studies, rent demand letter, cap rate letter, and they all have the same pool of base tables that they draw from and discussions, but they're different. The exact tables are different. So say there's 100 tables. Maybe this uses 20 of them. Maybe this uses 40 of them. Maybe this uses 60 of them. And they're just different. The ordering and the sequencing is different. And the table is the same. And it also varies. So within just appraisals, you might have an appraisal for Team Kelly and Template B. That was like one at Novogradic. Team Kelly did a lot of like syndicator work. The appraisal TDHCA, that's the Texas State Housing Agency one. They have special requirements, special tables that they want. This would just be like a generalized syndicator template. My point is that even within an appraisal, there's a lot of variation. So if you're automating the tables and you're automating the text, you've got to know how to get them and glue them together cohesively, in the way that the user wants them to be. Within one group of like an appraisal syndicator, you might have a senior subject, a special tenancy, mixed design. That means the subject property that you're valuing, it has some garden style units, and then it also has a low-rise building. Okay, and whereas most of the time, it's just one, all garden, all low-rise. But that changes the report. It can change how each table looks. So one individual table may now have to have an extra column inserted for structure. And it can also change what tables get injected into the report in the first place. A really hard one is scattered site. Fortunately, those are pretty rare. But that's where you're valuing one subject property, but it's got two locations. One of them is, downtown, and then there's another location 2 miles away. But they have the same management company. They consider themselves the same property. That makes it very hard to do things like, neighborhood analysis or locational amenities. How far is the nearest bank? 2.3 miles. Okay, that's simple when you only have one subject address. But when you have two subject addresses and you need to present tables that show how far away is, the nearest fire station, police station, bank, whatever. There's now two different start addresses to base from. So I hope I've shown you through these principles, like just the degree of difficulty. It's not just the tables. It's really easy to look at it and say, oh, I could do that table in Python. I'll just crush that with pandas, or whatever it is that you might be thinking, because I probably thought similar thoughts myself. But the more I got into it, the more I realized how difficult it was. So I think that I've gone on long enough. I'm going to stop this here. And what I want to do next, either in this video or in another one, is I want to actually walk through and just trace some of these values back and look at how, just to give you a sense. Just to give you a sense, because we talked abstractly about it, but let's go concrete and we'll actually trace through some of them. All right, I'm stopping. Okay, so if any of this stuff I'm saying is overwhelming you and you're planning to build in Python, you should be overwhelmed. If you're planning to build in VBA, you shouldn't, okay? When you break a big problem down into simpler parts, smaller parts, it isn't bad, okay? You start with your base models, and I'm going to show you that soon. How do you eat the elephant? One bite at a time. But when you're building in Python, it's kind of all or nothing. You can't do 2 or 3 tables and actually have people in production, go through all the trouble of getting access to Python and whatever just to do 2 or 3 tables, okay? I was struggling to word this, so I asked ChatGPT for help. I'm just going to read you ChatGPT's response because I think it's all right. When you're building a commercial real estate appraisal model, the reality is you almost never get to build the whole thing at once. It's an incremental grind. You might start by automating just the rent roll math. Later, you automate OPEX. 6 months later, you finally backfill the DCF model. A year from now, you do the reconciliation table. That kind of slow backfilled evolution is totally normal and expected when you're working inside of Excel with VBA. Nobody complains only half the buttons work. That's not true. Nobody is confused that some tables are manual while others are automated. That is true. It's still Excel. The existing template stays usable every step of the way. With Python, it's different. Python wants to own the whole output. It wants to you kind of see, you can finish reading this, all right? But the point is, you have a long period of value at risk. The whole collective gets together when you're doing Python. It's okay, we're gonna have the planning stage and the requirements, and you just picture the payroll and the expense. It's just it's completely inorganic and unnatural, synthetic, and that sort of like Gosplan style, project is in my view doomed to fail many of the time. All right, it doesn't. Your one company alone is not enough to justify, a full scale programming software team with that whole, lineup of people and software analysts and requirements and that. It's a long time deferred. And when you finally do get to use it and you find problems, it's like they're discovered too late. It's very expensive in terms of the time of analysts trying to sort of like explain to programmers how the business works. And a lot of times, like, you don't really know, like Warren Buffett, it's like only when the tide goes out, you see who's swimming naked. It's like some analysts might say, oh yeah, that looks great, or like I could use that. But then when they really get in there and they're really doing their report, that's when they're like, oh, wait, this is not right and this is not right. The casual feedback that you get from like an analyst in the hall who frankly isn't in the mood to be like, oh no, this sucks, this doesn't work. He doesn't want to get into that with you. It just doesn't work. And I've, spent many years, looking and examining that problem firsthand. So you can also pause and read this if you want, but ChatGPT's on board. ChatGPT's on board. All right, so now I'm going to hit stop, and we're going to go through I'll just take you on a little tour. You'll see what I mean. Okay, see you soon. Okay, so here's just some tables. I'm not going to go through in super detail. We're just going to kind of skim over the surface and look at some of the dependencies, okay, and the data sources for some of these tables. And you can imagine it's the same for the text. I just think it's more, I'd rather look at tables. And, I think your clients, for the most part, would probably also rather look at tables. Anytime you can put information into a table instead of text, I think it's a good idea. And especially when you're automating your tables, the calculus changes. Maybe it's easier to bang out a paragraph when you have to make the table by hand. But when the table is just like pristinely being created for you, the table can be a lot easier. That's just my view. So, okay, we're just going to follow these little hyperlink tour. This is the reconciliation table, okay? This is the final value that the appraiser concluded to in this fish pond appraisal, okay? The San Antonio property. And you can see the value here, 3.1 mil. And then somewhere was that reconciliation table. I think it's right here. The first thing to notice is that the income capitalization, the income approach and the sales comparison approach are the same value. What are the odds? And if you don't know, the income approach is where you and that's the one we're going to look at today mostly, is when you add up all the rents, okay, and that gives you revenue. You get all the revenue, and then you deduct all of the expenses, all right, to run the property, okay, to change the light bulbs. And what you're left with is your net operating income. You divide that by the cap rate, and that gives you, a back of the envelope stabilized value of the property. That's your income approach. The sales comparison approach basically looks at nearby properties that have sold, okay, and it gets their sale price and divides by the total number of units at that property. So you get a price per unit. And so they're both valid ways to value, the property, but you are, you're approaching from two different directions. As it happens to be, the income approach is the one that drives the show in the appraisal. Okay, so this is the one that really is like what clients care about and what it's the better indication of value. It's the better approach for an income producing property like apartments. Okay, sales comparison is better for like a single family home. And the cost approach, really nobody cares about it in this context. Is how much would it cost? You figure out how much would it cost to build the property brand new, and then you if it's 20 years old, you deduct some depreciation, because you have to take account that the property you're valuing today, it wasn't built yesterday. Okay, it's not in perfect condition. So first figure out what does it cost to build this thing brand new, and then you knock it down in value based on how old it was. This would be appropriate for like a church, I think is, one area where they use the cost approach. There's probably other ones too, but I digress. So these values are the same because the appraiser made them the same, okay? And they're the same in almost every report. It isn't a coincidence, okay? It's important to basically, they're trying to pin the value of the sales comparison onto the value that they already got from the income approach. And it's made more difficult by the fact that the caps, the sales that you use for your cap rate, remember, you take the total revenue minus total expenses to get NOI and you divide by the cap rate. So this 5.9% here, that's the cap rate. The same sales that you're using to determine your cap rate, which is flowing into your income approach, those are the sales that you use for the sales comparison approach, okay, for the price per unit. But they don't always work well together. Sometimes like everything's great in the income approach, but then you get to the sales comparison and it just doesn't line up. There's adjustments for the sales comparison. Maybe one of the sales, like there was tons of bed bugs or something, and the buyer was like, I want a $100,000 discount because I'm gonna have to fix these bed bugs as soon as I take over this property. Okay, in that situation, you add back $100,000 to that sale. You try to remove the influence of those factors. So it's not always obvious right away that these, building sale comps that we have are not going to work. I'm saying all this to point out like the nuance and the depth that goes into, it's more than what you can fit into your pandas data frame. Okay, so we're gonna work backwards. 3.1 mil, where'd that come from? Looking at the income approach, here's our revenue. Oh, here, wait, let's take the tour. Clicking this link, it's taking me right here. So there's your 3.1 mil, or right there. All right, so you can see, you've got revenue minus the vacancy, that's your effective income. You have total expenses of $301,000. That leaves you with $184K in NOI. Divide that by the cap rate, and you get your 3.1 mil. It's rounded. There's another little subtle thing right here. So 184K divided by 5.9% is not 3.1 million. It's something else. All right. You round by a number of digits. What number of digits do you round by? It depends if the value is above or below 10 million, or there's some limit. I think it's 10 million, whether it's 4 digits or 5 digits. Again, just like part of the stuff that you're going to have to get if you were doing this all in Python and you're a professional developer, that's like, all these like hidden requirements, which a business analyst just sort of knows, might forget to mention, will forget to mention. All right, so let's go. We're going to look at the revenue leg first, okay? Because like, where did this $503,000 come from? So let's go to the next stop, PGI. It's nearby. It's right here. Okay, so this is the potential gross income for the property. These values here of like the bedrooms, the number of units, and the square footages, that came from the remote, your web data source right here. Okay, so I call that remote data. You're importing that into your workbook. But the achievable rents, now, that is not. That is something that was concluded here in this workbook. The rent that you see here, the asking rent, that's, provided by the client. All right, so the appraiser doesn't take, it goes into the workbook, but the appraiser doesn't take that, at face value. The appraiser is going to independently determine what they think is the achievable rent. That matters more, I think, in a new construction project where nobody knows what the rents are going to be because the project has not been built yet. It's just an empty lot of land, right? And the developer tends to have, the real estate developer tends to have like really rosy, optimistic view of what rents are achievable. Anyways, so that's a human conclusion. So that human conclusion, this is not going to be stored up here. Unless you're building, a web-based Python, valuation platform, which I think I said in the last segment. I have done that, and it was excruciatingly difficult. There are so many edge cases and twists and turns. Let's see if I can stay on track. So, you figure out the monthly rent, you figure out the gross rent per month just by multiplying, 650 by 10 units. And then you multiply that by 12, you figure out the annual amount. You sum this column, you get 503, 700. So there's your 503, 700 for total revenue. Let me pause there because I don't hate this segment. Okay, it's a good thing I paused on the last segment because I went off the rails and I would have ruined that one. Okay, so we're gonna go down the revenue leg. I just showed you PGI, but where do these achievable rents come from? What I figured out when I was trying to explain the last segment is that it's hard to put into words. But what you can see here is that there's a lot of moving parts and there's forks. Sometimes an analyst will want to conclude achievable rents using grids, and sometimes they want to use a classic rent analysis. But basically, so there's all these different forks that it can go down. And not only are we figuring out the rents, for as the property is restricted to 50% of AMI or whatever artificial rent restriction there, but also figuring out what is the rent unrestricted. Even if the property is going to have affordable restrictions, the client still wants to see, well, theoretically, what would the market rent be if there were no rent restrictions? What they want is they want to see a discount. They want to see that the LIHTC affordable artificial low rent is actually like way below the market rent, because that basically will guarantee that there's a lot of demand for their units. If the LIHTC rent is basically the same as like the market rent, which does happen all over the place, that might not be a good deal because they're going to have to compete with regular market rate properties. So I don't think I should dive into the depth. What I was thinking is that what I really should do, and what I think I will do, is I'll just build out. I kind of just want to build it out. I could build it out on YouTube, and I could show you. I can build, I have a freaking, a web database with everything that we need for properties. I might build it out and just sort of like open source YouTube it. Because these reports, like, even though I worked at Novogradac, like, they all look pretty much the same when you look at, various appraisal shops. And I think that, the way I build it is going to reflect RCS, these grids. This is HUD. These are HUD's colors. HUD is a government agency. So I don't really feel like there's anything proprietary there. I also feel like right now, if you're an appraiser and you want to get into, doing affordable appraisals, it would be almost impossible to compete against Novogradac, my old employer, just because all the tables, all the text, this text here, the adjusted rents, blah 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 blah. That's I wrote the function that wrote this text. This text. So like we have taken Parco de Oro most into account in our rent determination as this property received the least amount of gross adjustments. Like, the script that I wrote, I call it like the Stalin principle, okay? It said, Stalin had this attorney general, and he told Stalin, he said, look, man, show me the man, and I'll find you the crime, okay? And so my take on that was like, show me your concluded rents, and I will show you a persuasive narrative supporting them. So when you input your rents, your concluded rent into this Python system that I built for Novogradac, it'll actually scan over that grid, find the comps, and it will find reasons. It'll look at your conclusion, and it will look at what comp is closest, and it will look for all the reasons that support using that comp. Basically, that support leaning towards that comp. I had another thing for attacking the outlier. So basically, Parco de Oro is helping us, right? We want to say, look, Parco de Oro is like, good. That's why, we concluded so close to it. It was a great comp. But then sometimes one of the comps is like way off the map. Like in this case, it might be, I don't know, maybe this 642 Rio Springs is not really helping the case for 725. Neither is the Howard Apartments. But the point is, it would attack the outlier comp and be like, this is a bad comp. It had lots of adjustments. You know, the more adjustments that you have to make in these grids, like if you don't have to make any adjustments for Parque de Oro, that's a great sign. It means that like literally it has all the same amenities, the square footages are almost the same. You know, that's a good indication of a good comp. Especially gross adjustments. Because the net adjustments would just mean there was tons of adjustments, like plus 100, plus 100, plus 100, minus 100, minus 100, minus 100. It's like, well, there was low net adjustments, but there was still a ton of differences in those properties. Let me stay out of the weeds. Yeah, but the attack the outlier turned into a problem because this discussion repeats. This is just the 1-bedroom grid, and then you have the 2-bedroom grid. So what would happen is in the 1-bedroom grid, it would basically attack a comp, like the Howard Apartments. Like, this is a bad comp. We're not relying on this. But then in the 2-bedroom grid, the Howard Apartments would be the one that was like really close to the concluded writ. So then the NLG, I keep using that term, natural language generation. You can call it a report discussion, call it an NLG, but I digress. It would then be all rosy about the Howard Apartments. It'd be like the Howard Apartments is a great comp. It had the least net adjustment. It's located right around the corner. And you'd be like, wait a minute, like one page back, I read that, you know, the Howard Apartments is like an outlier bad comp, you know, we attacked it. And now you're trying to say it's good. So ultimately we removed the attack the outlier from the program. It's fun though, to think about those kinds of things is fun if assuming you enjoy your work as an appraiser. Secondary units is when you pin off. So, you know, we have this 1-bedroom, we've got 1-bedrooms at 424 square feet, and we got 1-bedrooms at 450 square feet at our subject property. But in every other respect, they're the same. They got the same amenities, same number of bathrooms, same number of bedrooms. It's the same property, okay? Not just in the same neighborhood, but it's literally down the hall. So in a situation like that, you don't need to build a whole nother grid. Instead, you just whip out one of these secondary units and you say, look, we have this 424 square foot unit and we concluded using grids to 725, and you just pivot off that 725 and you make one little adjustment for square footage and you get to, 735. Anyway, so we have 735 for these 450 square footers and 725 for the 424s. Those numbers are going to flow right in here. 424 and 450, these two in the middle. Okay? So you can see the provenance, though, of the data and how everything is sort of connected. OPEX, sure, why not? Let's just go. Let's look at OPEX. This is what the operating expenses look like. So see at the top, here's our rental income. There's that 503,000, from here, which came from here, which was based on the rents from the RCS grids. Okay, and then this purple section here, these are human concluded rents. So the analyst is saying, look, we think our property, the restricted as-is condition, it could also be like as renovated, okay? Would have lower expenses as renovated. LED light bulbs. And they make these conclusions, but to do it, they have to see, the averages of the comp rents. Do I have a little mini table somewhere? I think it'll take us there. So, that was weird. Jesus Christ. Get out of here. Delete. We can't let this video segment go bad. So you can see this is sort of like what the analysts would want to see when they were concluding to the utility expense or any of the operating expenses. The minimum, the maximum, the average. I think that the median is also something that is good to look at. And you can see the coupling too with the text beneath it. So regional benchmarks. Okay, you need benchmarks for it's like only one spreadsheet of data, but there's like a benchmark for the current region that you're in and also the size. So a property that's, 200 to 500 units is gonna have a different benchmark expense for, admin expenses compared to, say, a property that has only 10, in the 10 to 50 unit bracket or whatever the brackets are. But my point is that's a remote data source, okay? That data had to come into the workbook. And let me land you with this. Because I think it strikes again at the challenge of, the grand collectivist scheme of having your fancy Postgres database running on your virtual machine and yada, yada, yada. If I come back to this report 3 years, I did 3 years ago, okay? So I go on the T drive, I find an old report from 3 years ago, I open it up. Like, I expect to see the benchmarks and everything locked in at the time of the report. Concluded rents, everything has to be frozen like a time capsule. So I call that the Han Solo principle because remember when he gets frozen in carbonite to be delivered to Jabba the Hutt? He's just frozen. And that's how a report should be. When you finish the report, you close your Excel workbook. It needs to be like hermetically sealed from the outside world. It doesn't matter if I change the rents up here for one of these properties that's in there. It doesn't matter. Like, those rents have already been copied in the workbook. They're frozen in time. Now I could open up the workbook and hit like refresh from web on that comp and it would suck the latest rents in. But that's not my point. Okay, I think that payroll. So you can see payroll. In payroll, you don't just like put in an amount for you don't just put in an amount the way you do for like admin expenses, okay? When you're doing admin expenses, you don't like add up like the amount of staplers you're gonna need, or the logic that goes in admin expenses is basically like if you're doing an affordable, if it's a restricted scenario that you're valuing, it's going to be a little higher for admin because you've got to qualify these tenants. They come in, the rents are artificially low, but you also can't just Bill Gates can't just live there, okay? Because there's also an income limit. So they have to like income qualify the tenants and make sure they don't make too much money. One of the most heartbreaking things actually is when like a family is like living there and mom or dad gets a promotion and they get a pay bump and suddenly they're not income qualified and they have to get kicked out. I don't know. I just think that's horrible. Anyways, back to my root point. For payroll, you actually conclude, okay, we have a manager, he's this much money, and we have a part-time maintenance technician. And it looks at payroll taxes or whatever. So you try to basically have a little more support, just like with achievable rents. Like, you don't just throw a number in there. You figure out what the achievable rents are for the units that exist, and then you kind of add up the revenue from that, deduct the vacancy. Same for payroll. You have to have some sort of like little narrative to go with it. I think that's it. That's all the points that I want to make. I had other ones, but it never goes quite according to plan. The idea is to see that just making this table, and it's like, you need to understand everything that came before. It's not making the table, it's being able to know what that 3.1 million is. And if you're doing this in Python, it's like, in order to make this table, you're going to need Python to know all of this other stuff too, okay? And you're going to need to have ways to get the human conclusions. Like, you're going to have to give them like input dashboards where they can input the values, save those values, give them metrics so that they can make informed judgments, and frankly, a lot of other things that I'm forgetting about. If you're doing this in Excel, I'm going to show you by actually building out a little bit of a model. It's much easier though. You start with your foundational models. Get an import script for the rent comps, get an import script for the units with those rent comps, get your amenities set up, and then you have this base model where you can just like play and build on top of it. Ultimately, I got a good spot to leave you. Hierarchy of desire, right? This is your base level valuation circuit, all right? First, you do this. Like, just get your basic tables, get your value circuits in line. And then you know, you can work on getting it injected into Word, adding validation, et cetera, and then this is sort of like reaching the top of the pyramid. You know, if you get up there, let me know how it is. I'm I'm somewhere inside of AI tactical nukes myself. Okay, I'm landing it. Cut.